All right. Good morning, students. This morning we shall be dealing with Pythagoras theorem. Pythagoras theorem. I'm making this video because you find it difficult to state it, and you're supposed to be able to state it properly. If you can't state it properly, then I doubt your knowledge of this topic. So let's get it right from onset. So I'm going to state it right now. Pythagoras theorem. Pythagoras theorem. If you don't want to say theorem, you can say rule. States that in a right-angled triangle, the square on, watch the word, on the hypotenuse is equal to the sum, watch this word, sum of, watch this one, of the squares, then on the adjacent sides, plural sides. If you don't want to use this adjacent side, this word, you don't want to use these two words, you can use other two sides. So that means that if I want to state this theorem, I will either say Pythagoras theorem or Pythagoras rule states that in a right-angled triangle, the square on the hypotenuse is equal to the sum of the squares on the adjacent side. Or I can say Pythagoras rule states that in a right-angled triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. That is the way I want you to be defining Pythagoras theorem from now. Then I showed you the hypotenuse and I showed you the adjacent sides. I'm going to do that again right now. Look at this. You have a right angle triangle like this. This is 90 degrees. That is what determines the hypotenuse. This 90 degrees, this is what is facing the 90 degrees. You can see it's facing the 90 degrees. That is what we call the hypotenuse. All right. So these other ones, this one here and this one here, two of them put together are called adjacent sides. They are called adjacent sides, or you can just call them other two sides. Right? Good. Please note that properly. So it is the 90 degree that determines what the hypotenuse will be. So it depends. Sometimes they can even draw the triangle like this and put 90 degrees here. So you will see that this is the hypotenuse now, and these ones are the other two sides. So if I call this one A and I call these other two sides B and C, that means that the square on the hypotenuse, A square, is equal to sum of this one square and this one square. Do you understand? So it is the hypotenuse that determines what I'm going to write. All right. And I also need you to note something from now. If I am looking for the hypotenuse, I will use plus here. Okay? But if I'm looking for any of the other two sides or any of the adjacent sides, I will use minus and I will put hypotenuse in this place. Let me show you what I'm talking about. This is hypotenuse. Assuming I'm not looking for hypotenuse and I'm looking for any of the other two sides. Say I write b square equals, I'll write the hypotenuse first, then minus, I've used a and b, the last one, c square. If it is c I'm looking for, then I will write hypotenuse again, minus the remaining one, which is b square. And we took examples on this the last time we met. So go back and check those examples and compare it with what we have just done. So I'll just give examples of the part of the topic that I plan to teach today, which is called Pythagorean triple. Pythagorean triple. I'll give an example of that quickly. That is three numbers that will perfectly fit into the Pythagoras theorem. Three set of numbers that will perfectly fit into the Pythagoras theorem. See the one we used in the last lesson. You will see by yourself. This is 90 degrees. This one is 3. If this one is 4. And I ask you to find this place, x. So you know this x is the hypotenuse. So you use x squared equals, I just wrote it a few minutes ago. And this one will be 3 squared plus 4 squared. You can write any of these numbers first. This is 9 plus 16. Check your notes. You find it. We did it last time we met. 25. So I'm looking for x now. It will be square root of 25. So my x will now be equal to what? 5. Alright, I'm a bit fast now because we did it last time. So I'm just using to explain Pythagorean triple so you can understand. So it means this one is 5. Now, when I put all of them together from the smallest to the biggest, this is 3, comma, this is 4, comma, and this is 5, comma. All these ones, everything put together is called Pythagorean triple. So this is a Pythagorean triple. Okay? So, master that. So anyone that fits into it is called Pythagorean triple. Let me give you another example very quickly. Don't forget that you have a right to pause the video and to play it over and over again till you master it properly. That's why I'm making the video actually. If I come over here now and draw another, okay, let me change the way the triangle is. Say I draw it like this and I put it like this. And I call this place 13. Alright? And I call this place 5. And here 90 degrees. And I say find this P. Find P. You will see that this P I'm looking for is not facing the 90 degree. So the P is not the hypotenuse. The P is one of the adjacent sides, or the P is one of the other two sides. That means I'm going to be using minus. I just explained it. I'm going to be using minus. So for me to find P now, I will say P squared is equal to, I said you will write the hypotenuse first. 13 squared minus then 5 squared. If you remember, if you think you can't remember, quickly rewind the video to where I was explaining it. You will find it there. And this one is 169 minus 25. When you subtract this one, you will get 144. So for you to now get P, you know this is square. This is P square. For you to get P, you find the square root of 144. You are all used to that. So that the P will now be equal to 12. This is 12. So when I want to write the Pythagorean triple now, that means that from the smallest 5, 12, 13 is also a what? A Pythagorean triple. I'm sure by now you have mastered it. So when you see a set of number that can fit into Pythagoras theorem, the last one you see here is the biggest of all the three numbers. Even if I put it here or put it here, the biggest of the Pythagorean triple is the hypotenuse. When I did the other one, 5 was the biggest of the number. I had 3, 4, 5. 5 was the biggest of the number, and that was the hypotenuse. In this one, I have 5, 12, and 13. 13 is the biggest, and it forms the what? The hypotenuse. All right. So now, let's go to another diagram. I'm going to be combining two right angle triangles now, and we'll just solve either one or two examples to explain Pythagorean triple. Then I'll give you a list, but just a very few lists for you to remember. Now, what if I have a diagram like this? Say I have a diagram like this. Okay, this one coming like this, and going down, coming this way. All right, and say I have this one, make it into 90 degree. So here is 90 degree here. Here is 90 degree here. If you look at it properly like this, there are two right angles. Let me call this A, B, C, D. We have two right angle triangle. One of them is triangle A, B, D. Another one is triangle B, C, D. That have two right angles. This is a right angle, another right angle. So here I can use Pythagoras theorem to solve it. I can also use Pythagoras theorem to solve anything I have in this place. So now let's assume that they gave us 4 here, and they gave us 3 in this place. They put x here. They asked us to find x. And they put y in this place. They asked us to find y. And they call this place 13. Now, one thing you have to note, all right, is that when they combine two triangles like this, and they ask you to find any of the sides, now, you will need two known values and one unknown for you to be able to solve any triangle. Two known values and one unknown for you to be able to solve any triangle. So if you think, because this triangle is starting from here, I want to start from this one. Look at it. You know this one. You don't know this. You don't know this. So this one is against my rule now. My rule says that you need two known and one unknown, so that this one unknown is the one you'll be looking for. So in this triangle now, you will discover that we have two unknown. Can you see? So it means I cannot solve this one yet. But when you come to this triangle, you will see that we have two knowns. So it fits into my formula. So I have two known, one unknown. So I can solve this one first. So you start with the one that has two knowns and one unknown. That is my rule. Please put it in your head and don't forget. You need two known and one unknown. So let's go on now. You will say from triangle, name the triangle anyhow you like it. Triangle BCD, I want to solve it now. Okay? So I want to use Pythagoras. Using Pythagoras rule. Now, why am I using Pythagoras rule? Because it has 90 degrees. And this one happens to be the hypotenuse. So I know I'm going to say x squared equals, I'm going to sum these ones. Don't forget, you have the right to do what? To rewind the video. And this is what? 16. And that gives you 25. By now you should be used to it. And this is square root of what? Is square root of 25. And the answer here for x is 5. So this x is now 5. Can you see we have solved that now? Now, because we have solved this one, it is now easy for us to solve this triangle. Why? We now know two knowns. Because this line is now 5. It's now 5. So we know this one. We also know this one. So we have two knowns now. So we can solve for y. So we can also say from triangle, look at this triangle, ABD, using Pythagoras rule. Using Pythagoras rule, so I'm going to do it right now. And this side is not facing the 90 degree. So it means this one is the what? The hypotenuse. So I want to solve the part that is not facing 90 degree. And by now, everybody should know what I'm supposed to do. So what will I do? That will be y squared. Because it's not the hypotenuse, I'll write the hypotenuse, I will square it, and subtract this side, which is 5 from it. And we have done it today. You know, when I was giving an example of something. So, and this part, if you look at it, it will give you 169 minus 25, which happens to be 144. Which happens to be 144. So that 144 helps us to know that our y is equal to square root of 144. and that is what? That is 12. That is 12 centimeter. So that tells you that this part I'm looking for is 124, is 12 centimeter. And if you look at everything properly, you see we have two Pythagorean triple, which is what? This one is now 12. So two Pythagorean triple. The first Pythagorean triple is 3, 4, 5. The second Pythagorean triple is 4, 12, 13. It's 4, 12, 13. All right? So please, like I said, you have the right to rewind the video and go over it, till you master it. So I will give you an assignment to solve right now. I give you an assignment to solve right now, and I want you to take your time and follow the principle I've taught you to do the assignment. So here comes the assignment. I'm giving it to you now. So you pause the video. After writing the assignment, you pause the video and take the assignment from the video. So I'm putting it on the video. I'm not going to paste it because I want people to watch the video. So if you don't watch the video, and I'm even putting it in the middle of the video, so you have to watch the video to know that there's an assignment there. So the diagram I'm giving you is like this. Then come down like this, form 90 degree here. Then you have this one coming like this, and this one going like this, coming another 90 degree and coming out of it like that. So here is going to be 21. I want you to find this place M, all right? And here is 20. So I also want you to find this place MN. Find N. Why this one is 99? Beautiful. So let's do it that way. So I've given you this. So this is my assignment. Putting it right at the middle of the lesson. So find M and N. Now, you can find anyone first. If you think you want to find this one first, no problem. If you think you want to find this one first, no problem. Just find M and N, and that is the assignment. So you have to pause it when you are watching it to do the assignment. So I want to give you, a list of Pythagorean triple. Then I'll give the assignment from that one too. Okay? Few list of Pythagorean triple. So let's take this one. I have 3, 4, and 5. You are used to it already. You can also have 5, 12, and 13. You have seen it today. 5, 12, and 13. You can also have 8, 15, and 17. You can have 9, 40, and 41. You can have 11, 60, and 61, and many of them. So your assignment on that, making 2 assignments. Complete the following Pythagorean triple. Just complete it. 1. What if you have 11-61? You feel what this place will be. Just put the answer there. Number 2, you can also have 16. Okay, let me fill this one. 1663 dash. So complete this one. Number 3, let me give you something big. 28 dash 40. Okay, 43 dash. Let's not give the last one here, and let's make it dash 143. That's a big number. And 145. So fill the Pythagoras. Don't forget I told you that this last one is always the hypotenuse. It means in this place you are given the hypotenuse. In this place you are given the hypotenuse. So you are looking for one of the other 2 sides. You know what to do. Try it. Then this one, you are given the other two sides, which is the adjacent sides, and they have to find the hypotenuse and to know what to do in that case. So that ends the lesson for today. Feel free to rewind the video over and over again till you master it properly. Do have a wonderful time, and bye for now.